All right, lightning fast this morning, guys. Who's going to tell me the difference between a vector and a scalar? Good, good. Vector has both magnitude and direction, whereas a scalar has only magnitude. Who can give me an example of a scalar quantity? We talked about, I believe it was 6 different quantities yesterday. We talked about distance, position, displacement, time, speed, and velocity. Some of those are vectors, some of those are scalars. Which ones are scalars, please? Give me one. Good. Distance is a scalar. What's the symbol for distance, by the way? Go ahead. Yeah, D or a triangle D or delta D. Good. Usually we use delta D for distance. The units that we use for distance are going to be typically meters, although we can use other units as well sometimes. But usually we're going to go with meters. If ever in doubt, go with meters. And of course, we said it's a scalar. Give me an example of a vector quantity. Distance was scalar. Okay, so we got one on this side, scalar. Give me an example of a vector. Good. Go ahead. Time is not a vector. No. Good, good. Velocity is a vector quantity. So we've got distance as a scalar, and you mentioned time, and you mentioned speed as well. Velocity is a vector quantity because direction matters. Okay, what's the symbol for velocity? V with a little half arrow over top of it, right? As opposed to speed, you said, which was the scalar, which is V without the half arrow over top of it. If you're ever confused about what's a vector and a scalar, look on your data sheet. Okay, we'll get you a data sheet in the next day or two. Look on that data sheet. If it has a vector sign over it, it's a vector. If it doesn't, it's not a vector. Okay? If it's a vector, it has direction, like velocity. If it's a scalar, like distance or speed, it doesn't have direction. What were other terms? We had time. What was that? Vector or scalar? Scalar, good. Some people kind of say on that one, well, we kind of go forward in time, right? So there's kind of a direction, but it's not the direction that we're talking about here. Okay, we don't go 3 seconds to the left. Okay, we might go 3 meters to the left. Might be a displacement 3 meters to the left in 3 seconds, but the time is a scalar quantity. There's no direction associated with that. So what else do we have? We had position, vector or scalar. Good. What does position mean, by the way? Distance is how far something's traveled. Look at position. Yep. Good. Where something is. And it's a vector. Okay, so it's going to have that little half arrow over top of it, and it's going to be that symbol D. That symbol D with that half arrow over it. And the units we use are going to be typically the same thing we use for distance, which is meters, usually, although not always. We had, I believe, one other one. It was displacement. Vector or scalar? It's going to be a vector quantity. Good. What's the definition for displacement? It's not where you are, but rather it's the change in where you are. It's the change in position. So the symbol for it is going to be the symbol for position with a little change symbol right in front of it, the delta right in front of it. Delta D with the arrow over it, displacement, the change in position. The units are going to be meters, and of course we said that's going to be a vector quantity. Good? I want to write an equation on the board here right now, and I want you to tell me what it finds. V equals D over T. Delta D over delta T. What's that used to find? Yep. Good. It's used to find speed, as opposed to this equation, which is used to find good. It's the velocity. Speed versus velocity. No vector sign versus the vector sign above there. Are we good there? All right. Now, sometimes you're given the distance and the time, or the displacement and the time that you've got to use to find velocity. Sometimes you're not. Sometimes you've got to find it. When we're looking for a distance, a total distance, given other distances, then we're simply going to add those distances up, right? We say Martin walks 10 meters, then he walks 5 meters, and then he walks 20 meters, and then he walks 12 meters, all in a time of 50 seconds, what's his average speed? Well, we're going to add those distances up, put it in right here, and then divide by the time, right? Easy enough. But what if he walks, what if we're looking for the velocity, not the distance? Well, then we need directions. And of course, because of that, we need displacement. There's two ways that we find displacement depending upon what we're given. Displacement, we learned yesterday, can be found by taking the final position minus the initial position, right? Where you are now, taken away from where you were in the beginning. Sorry, the other way around. Where you are now minus where you were at the start of the problem, the final position minus the initial position. The other way to do it is to find, or is to add displacements. So let's add up your displacement in one phase of the problem to the displacement of the next phase of the problem. And that can be a little bit confusing. See, delta d is equal to df minus di, and then delta d is equal to d plus d. It's all what d means. Okay? df and di are positions, where something is now versus where something it was before, as opposed to delta d, which is how far something's gone. The displacement over an interval added to the displacement over another interval. Okay, I'm going to give you a couple examples here, and I want you to tell me whether we would subtract these numbers to get displacement, or whether we would add these numbers to get displacement. Okay? I am 3 meters from the front of the room. I take a little walk. Now I'm 9 meters from the front of the room. If I wanted to find my displacement there, would I add 3 plus 9, or would I subtract them? Hands up if you think you know the answer there. Add or subtract that 3 and that 9? Pardon? We would subtract them. Good, because those are positions. Those are two places where I am or was. I was at 3 meters. Now I'm at 9 meters. Those are two positions. We've got to subtract those to get displacement. Okay, let's try another one. I walk 2 kilometers to the south, and then I walk 5 kilometers to the south. Would I subtract those to get displacement, or would I add those to get displacement? I walk 2 kilometers to the south, and then I walk 5 kilometers to the south. Add or subtract? We're going to add them. Good. Those two numbers that I gave you, those 2 and the 5 kilometers, aren't where I am and where I was. It's how far I've gone. My displacement was 2, and then I had another displacement of 5. So if I want to find my total displacement, I've got to add those together. Does that make sense? Okay, the difference between I was 3 meters from the front, and now I'm 9 meters from the front, subtract them, versus I walked 2 and then I walked 5, we add them. Okay, good. All right, yesterday I believe we left you with an example problem that I asked you to copy down. I told you the story of where this came from yesterday, I think. First time I drove across Canada when I was 23 years old, when I moved from Nova Scotia to here. I got to Regina, this side of Regina, and then I saw this big sign that said Calgary, and I was excited because I thought it was going to be like a half an hour away. And then it said, as I got closer, 750 kilometers. I wasn't real excited about that because that's a long drive. Yesterday we talked about how we all look at signs like that and we all kind of estimate in our mind how long it's going to take us to get somewhere based on how far we are away. We all recognized, I think, that at some level we use the equation v equals delta d over delta t whether we realize it or not. We're just going to formalize that today. Let's take a look at this question in a little bit more detail now. The givens in this question, what we have given to us. It says Regina is 600 kilometers west of Winnipeg. Is that a displacement or is that a position? Is that how far Regina has traveled, or is that where Regina is? Is that a displacement or a position? It's a position, right? Regina hasn't gone anywhere. Okay, some people wish it would. but it hasn't gone anywhere. It's exactly where it was yesterday and the day before and the day before that. Okay? It is 600 kilometers west of Winnipeg. So we're going to call this D1, or let's write it down here. My initial position. D1 is 600 kilometers. DI we're going to call it. DI. My initial position, 600 kilometers. Now, it's west, so we really should indicate the direction somehow. We get a couple of options for that. The way that I would suggest you do it is to define, in the beginning of the problem, west as positive. Had we defined east as positive, which would be okay to do, then my initial position would not be 600 kilometers. Rather, it would be negative 600 kilometers. Does that make sense? I don't care which way you do it. East is positive, west is positive. The only reason I define west as positive here is because both of these numbers are west. So it probably makes sense to go positive. But if you want to make east positive, which is actually more common, then we're just going to make my initial position 600 kilometers. All right, Calgary is 1,350 kilometers west of Winnipeg. Is that where Calgary's gone? Its change in position? Or is that where Calgary is? Calgary is in a particular spot. It's its position, right? The position of Calgary relative to Winnipeg. We're going to call that DF. The final position of this driver is 1,350 kilometers. And since we defined west as positive, we're going to leave that as a positive value. Now, yesterday when we wrote out that chart of the different variables, position, time, distance, and so on, we said that there's actually two symbols for time. There's T and there's delta T. This one's going to be a delta T because this 8 hours is a time interval, right? 8 hours has gone by during my trip from Regina to Calgary. If I wanted to call it T, then I would have to have a number that represents the time at a specific moment. Right now, it's 11:17. That would be T. Okay? Our assembly lasted a half an hour. That's delta T. It takes 8 hours to go from Regina to Calgary. That's delta T. I left Regina at 1 o'clock in the afternoon. That's T. Delta T here is 8 hours. Now, we said that the standard units for position are meters, and the standard units for time are going to be seconds. But in this case, we don't have to go to those standard units. We're okay when we're using this one equation that we learned yesterday in going with other units, as long as we recognize that and reflect that in our final answer. So we're going to stick with that today. And then when we have to use meters and seconds, I'll point that out. Okay, we want to find the average speed. The average speed is distance over time. Do we add these two numbers or do we subtract them? Are they positions or are they displacements? Somebody told me a few minutes ago when I started at 3 meters from the front of the room and I ended at 9 meters from the front of the room, two different positions, then we had to subtract those numbers to get the displacement. These are positions, right? The total distance traveled is not 1,950 kilometers. The total distance traveled is 750 kilometers. Right? Two positions, subtract. Two displacements, add. We divide that by 8.0 hours. And I think when we do that, I think we get 93 kilometers per hour. Is that right? Yes. Now, how many of you are familiar with significant digits? Okay. We'll talk about that more as time goes on. This is the correct number of digits for my final answer. I have to round it to 93, not 93 point something, because my least precise piece of data was 2 digits. If you're not comfortable with that at this point, don't panic about that. We'll talk about that more as we go on, okay? Always remember, though, just go to the least precise piece of data and round your answer to that number of digits. All right, let's do question B, the average velocity. Sounds almost the same. It's not distance over time, it's displacement over time. What's my displacement? 750 kilometers to the west. Right? The only difference is that it's to the west now. Now, since we're talking about a vector here, we've already got our direction defined for vectors. West is positive, so we can just write it the same way. Divide that by 8 hours. We get 93 kilometers per hour. Same thing, right? This 93 kilometers per hour doesn't have a direction associated with it because it's a scalar. This one does because it's a vector. What is that direction? If my displacement was to the west, my velocity is to the west as well. Now remember one other thing that we said yesterday. We said that distance and displacement are always going to be the exact same value until we change direction. When I drove from Regina to Calgary, I went in a straight line. Okay, literally almost a straight line from Regina to Calgary. I think there was a hill somewhere west of Medicine Hat. Other than that, you could pretty much see Regina from Calgary, just about. Because we don't change direction here, because it's all this way, the distance is the same as the displacement. And therefore, the speed will be the same value as the velocity. Had I gone this way and then turned around and went back this way, then my distance would be different than displacement, and speed would be different than velocity. That kind of makes sense? All right, let's try this one. This question sounds a lot like the last question, although our distances are obviously a lot smaller. It says a hiker walks 300 meters east, then 1,200 meters west. We get two numbers right off the top there. Are those positions or are those displacements? Is the hiker at a specific spot and then another specific spot, 300 meters and 1,200 meters, or has the hiker traveled 300 meters and then 1,200 meters? Positions or displacements? Yep. They're displacements, yes. The last question, Regina is here. In this question, the hiker walked this far. So in the last question, it was position. In this question, it's displacement. Let's write down D1, we'll call it. Displacement 1 is 300 meters. Let's make east positive here, okay? That makes displacement 1 positive 300 meters. Then this hiker walks 1,200 meters to the west. That's not where the hiker is. The hiker isn't 1,200 meters from something. The hiker walks 1,200 meters. The hiker's traveled 1,200 meters. The displacement of the hiker in the second phase of this question is 1,200 meters. We're going to call that D2, or delta D2. That's 1,200 meters, right? Or is it? Waiting for somebody to tell me here. Good. Good. It's negative 1,200 meters because it's to the west, and we defined east as positive. Now, you could technically avoid the negatives and positives and just put in east and west. I wouldn't recommend that. Okay, it's going to get a little bit cumbersome if you try doing that. Now, this took the hiker 1,800 seconds. That's going to be a time, right? Is that t or is that delta t? Is that what time it is on your watch, or is that how much time has gone by? T or delta t? It's a time interval, right? It's how much time has gone by. It's delta t. We want to find the average speed. We're going to find that by saying the distance over the time. What's the distance traveled here? Are we going to add these together, or are we going to subtract them? We're going to add them. Good. If we have two positions, we subtract them. If we have two displacements, we're going to add them. In the last question, we had positions. We subtracted. In this question, we have displacements. We're going to add them. What's the total distance traveled here? 900 or neg 900? No. The total distance traveled is 1,500. Why did I ignore that negative sign when I added these up? I wrote it down. Why did I ignore it? Really? Right. Distance is a scalar. You don't travel a negative distance. Now, when we start talking about displacement for velocity, then we better pay attention to that. But when we're talking about speed, it's a scalar. Distance is a scalar. We drop every direction. We don't care whether we're east or west. We went 300 meters, then we went 1,200 meters. My distance traveled was 1,500 meters. My time interval was 1,800 seconds. And I believe that is 0.83. Is that right? 0.8 would actually be 0.833 meters per second. It would be 3 digits because our least precise piece of data is 3 digits. So real similar to the last question, but big difference too. E equals d over t, but we got to add these together as opposed to subtract them. Now let's find the average velocity. It's displacement over time. We're going to add them together again, but this time because we're talking about displacement, we have to pay attention to the direction. 300 plus negative 1,200 gives me negative 900. That makes sense? We divide that by 1,800, and we end up getting negative 0.500 meters per second. And that negative means it's to the west. So we could say 0.500 meters per second west. This time, my speed and velocity are different. Can anybody tell me why? Just a few words, a few quick words. Why is the speed and velocity different? But in the last question, it was the same, besides the fact that the velocity had direction.
On the last question, the direction was the same.
Good, excellent. In the last question, we didn't change direction. In this question, we did. When you go in the same direction, the speed and velocity will be the same. When you change direction, the speed and velocity will be different. Okay, what would have happened if he had to walk 300 meters east and then 300 meters west? What would his average velocity have been? 0, because he would have been back where he started, right? Good. All right, we're going to wrap it up there.